All right, welcome back. We'll continue our compound interest videos. We will be understanding and using compound interest. In fact, in this case, we'll actually be using this. And so I'm going to go ahead and recall the formula in the next slide when we first do our example. So here, this is sort of given. So I'm going to go ahead and rewrite the formula. Remember that the formula is that we have that the amount that we're of our investment, after so many years is the principal. This is the amount that we invested times 1 plus the rate over n, which is the number of times that we're compounding, raised to the power nt, where t is in years. And so in this example, hopefully you'll see that the amount is here, 17,250. So we go ahead on this equation, just write down 7,250. And then the principal in this problem is 15,000. So I'm going to go ahead and write 15,000. And then we have the formula 1 plus r. Now here r is 3.5%, but we have to do this as a decimal. So that usually means to take the decimal place over twice. So 0.035. We're dividing by n. Weekly, if you remember the last video, hopefully you wrote it down, weekly means that n is 52. So I write 52 down here. Then the power is 52 times t. And so the goal says, notice that we want to find t. That's what we have to do. And so our goal is to figure out what this number is right here. Okay. Now you can trial and error if you want. You can start plugging in numbers for t and plugging this into your calculator and see what happens. But we're better at algebra. We're very good at algebra, so let's go ahead and solve. Now the idea here is to isolate the purple expression. Okay, so we want to isolate this. So isolate. And the way we're going to do this is by dividing by 15,000. So let me erase that piece just so you know. What I'd like to be able to do is take both sides and go ahead and divide by 15,000. By the way, for most of these problems, you're going to need a calculator, so feel free to pause and come back when you have one, or to use your phone. And so here what happens is that these 15,000s cancel. And so on the left-hand side, when you divide 17,250 by 15,000, you get 1.15. And on the right, you get 1 plus 0.035 over 52 to the 52t. And you can leave it like that, or if you want, you can plug in this number here. Just plug it into your calculator, and if you do that, what you'll get is 1.000673077. Keep every number that your calculator gives you. That way you'll get an answer that's close to what the book says. I don't round off until the very, very end. That's a kind of a mistake that many people do when doing these, is they round off too soon. All right, so here I want to know what t is. Now the problem is, the issue is that the t is up here in the exponent, and so it'd be nice if we knew how to bring it down. But it turns out that we do know how to bring this down. If you've been doing all your homework, then you know that you can take a log. And remember, there's this rule. So let me write down the rule over here on the side. There's this rule that says that if you have any log, any base, and there's a number here on an exponent, you can bring that exponent to the front. And so since it works for any log, the log of our choice, most of the time for us, it's always the natural log. So I would actually take the natural log of both sides. And so that means that we have this function, natural log, and inside of it, we put in the stuff that's on both sides of the equation. So 1.15 on the left, and on the right we would put in 1.0673077 to the 52t. And what this accomplishes is, on the left-hand side, nothing changes. I still have natural log of 1.15. But on the right-hand side, that 52 comes down. Remember that 52 is multiplying t, and remember that when you bring it down, there is a multiplication sign, so this is multiplying the natural log. And you can plug in the natural log. You will get a number. Okay, here we go. Sorry, this takes a while to write. And so now what I want to do is solve for t, but everything's being multiplied. everything's being multiplied. Since I want to isolate the t, the best thing here is to go ahead and divide. So I divide everything by 52 times the natural log of 1.000673077. And then over here, I do the same thing on the left, divide by 52. And here's where the calculator comes in very, very handy. I don't expect you to do this by hand. On an exam, either I give you some values or I let you use a calculator. So we'll figure that out when we get there. And then we just do our cancellation. 52 cancels here, the natural log cancels there. On the right, I'm left with t. This is where you might need to come and ask me for help in class. I want you to plug this in your calculator. If you plug it in correctly, you should get t is approximately 3.99. I said 99 and I wrote something else, 3.99. And so that's how many years? So it's almost 4 years. So it takes almost 4 years. And that's the answer to our question. Remember that here, our original question was find t. Well, we did. It took for about 4 years. Okay, let's go ahead and try another example. Very similar to this. So in this case, we're told to find r. We're given a. So again, I always, by the way, when I want to memorize an equation, I write it down for every problem, and this helps me sort of memorize it. So for the test, I don't have to worry about forgetting it. So this is our formula. I should have told you to pause, and then you should try to see if you can remember it. Every time, try to see if you can write it down every single time you do this. Okay, so in this case, they told us that after 10 years, we'll have $50,000. We invested initially $25,000. They don't tell us what R is. That's what they want to know. So there's R. They tell us N is compounded quarterly. So compounded quarterly, when you see quarterly, this means N equals 4. And then our T is 10 years right here. So that'll be times T, times 10. And so when I work this out, I'm going to get 50,000 equals 25,000. I forgot to do something. This N should have been a 4. Okay. And then it's going to be 1 plus R over 4 to the 40. All right, so again, the idea is let's isolate the stuff that has a variable. This is the part that has a variable. So if I want to isolate, why don't we divide both sides by 25,000? And this should be easy. You hopefully don't need a calculator for this. 50,000 divided by 25,000 is 2. And I get 2 equals 1 plus R over 4 to the 40th. Now I want to get rid of a power, and I was thinking of taking the natural log, because we just did that, so it seems, why don't we do it again? But it turns out that in this problem, that's not what you want to do. We only did that because the variable was in the power, but here the variable is not in the power, and so there is another way to get rid of this power, especially if it's a number. Whenever the power is a number, we know that we can take the 40th root. So we can go like this. What's the 40th root of 2? Take the 40th root there and take the 40th root right here. I know this looks really weird, but we are allowed to do this. This is what we learned before, and so I don't want you to forget that. And so on the right-hand side, the 40th root of the 40th power cancels each other out, and so you're left with 1 plus R over 4. On the right-hand side, if you want to plug this into your calculator, the easiest way is to do 2 to the power 1 over 40. Now this isn't too bad. Here what I would do is subtract 1. And so I get 2 to the 1/40th minus 1 equals R over 4. And then I just multiply everything by 4. So 4 times 2 to the 1/40th minus 1 is equal to R. And I actually I have a graphing calculator, so I plug it in right now like this. It's the easiest way to get the right answer. And so in this case, we get R is approximately 0.0699, which means that we can think of R as approximately 6.99%. Okay, we have 2 more examples. That'll be on the third video. So hopefully this helps. Go ahead and try your homework.